a perfect square. So we're going to have to do a little factor tree. 4 times 5. Now 4 is a perfect square, so the square root of 4 is 2. And 5 just comes down. So that's going to be 5 square root 2. Okay, let's look at number 19, square root of 48. Now a couple ways to do this one. Okay, I can take the largest factor that I know, and I know 16 times 3, it multiplies to 48. So I can actually factor this down as 3 times 16, and then 16 is a perfect square, and its square root is 4, so that means that's going to be 4, and I'm left with a square root of 3. Okay, now there's another way to do that one. If you did it a different way, that's fine. Okay, let's look at number 20. We have 3 square root 9. Okay, 3 square root 9. Well, the square root of 9 is a perfect square. It's 3. So I have a 3 on the outside, and then the square root of 9 is 3. So I'm just going to take those and multiply them together. So that answer is actually just 9, because 3 times 3 is 9. So whenever you simplify, you're going to multiply by that coefficient in front of the radical. Okay, now 12 factors into 4 times 3, and 4 factors down to a perfect square of 2. So I'm going to take a 2 out. So 2 times 5 gives me a coefficient of 10 on the outside. Now we don't have, 3 is not a perfect square root, so I'm just going to bring it down. So the answer is 10 square roots of 3. Okay? And let's look at one where we're doing a fraction. We call this rationalizing. So we have 3 divided by the square root of 5. Okay, to simplify that, you can't have a square root in the denominator. So we're going to rationalize that by multiplying by that square root. So we're going to multiply by the square root of 5. Okay, so the square root of 5 times the square root of 5 is the square root of 25. I always say the inside times the inside. If it's inside the radical, you can multiply them together. So that would be the square root of 25. But we know the square root of 25 is just 5. So when you multiply a radical times itself, that number does just come out. Now on the top, in the numerator, we have 3 on the outside and the square root of 5 on the inside. You cannot multiply those together. So it's just going to be 3 square root of 5, and that's your final answer. So that's how you rationalize. Okay, let's look at 23. On this one, there are a couple ways to do it, but I like to think about it this way. If we have values in the radical or radicans, you can just reduce those. So I'm looking at this thinking, what number goes into 12 and 27? And the answer is 3. So I can take a radical 3 out of each one of those. So basically just divide the top by radical 3 and the bottom by radical 3 by factoring out a radical 3. And that leaves me square root of 9 over 4 square root, and 12 divided by 3 is 4. Okay, now I have 2 nice radicals, because the square root of 9 is just 3, because 9 is a perfect square. And we have 4 times the square root of 2. Well, the square root of square root of 4 is 2. So 4 times 2 is 8. So the final answer is 3/8. Okay? Now there's some other ways to do that, but to me that's the simplest way. If you can reduce both radicals, then go ahead and reduce them.